So today we're going to be wrapping up 7.2. So we started it last week and we didn't get through all of it. Well, I opted that it probably should be done in multiple days, so we just pushed the rest of it to this week. So this is just 7.2 continued. So what we did last week was we looked at multiplying and adding and subtracting matrices. Some of them you had to do by hand, some of them you had to do on a calculator, so I still have to check that homework, but hopefully I'll be able to get to that shortly. But today what we need to pick up on is stuff like 29 through 42. So the first thing is we're solving for A and B. So solve for A and B. So basically you're given two matrices that are equal to each other and you're figuring out what A is equal to and what B is equal to. So we are going to start with number 30. So we have the matrix 1, negative 1 is 0, A, negative 2, 1 is equal to 1, B, 0, 3, negative 2, 1. So notice, same amount of elements in each one, same number of rows, columns. So that means I can just take whatever is in the place here and they should be equal to each other if this is true here. So that would mean that B is equal to negative 1. Okay, I'm just working my way down. And then that A, it's in the first spot, so it would be equal to 3. And that's all you have to do for those ones. Alright, but obviously they do get a little harder. So let's look at 32. So we have A plus 3, and then we have 2, 0, and 5 is equal to 4, 2, 0, and B minus 1. So same process, but it just takes like one extra step. So just so we can see it, I'm going to set it up. You guys probably could just say what it is without having to actually set it up. But A plus 3 is equal to 4. So A is equal to 1. And then B minus 1 is equal to 5. So B is equal to 6. And that would be your answer for that one. So really pretty easy. Just one more little step that you have to do. And you could really leave out that step here of writing this. I'm just doing it so you see it. But you guys are smart enough to pretty much be able to see that. What minus 1 is equal to 5? I think you guys can do that. So then the next section down says verify that the matrices are inverses of each other. So because these ones are not 2 by 2s, you get to use your calculator to verify them. So just as a refresher, for these, to find the page I'm looking for. Maybe I did not write that down the other day. But basically, an inverse, you have to show that A times B, or matrix A times matrix B is equal to matrix B times matrix A, which should be equal to the identity matrix. So I guess I didn't actually write that down the other day. So just so that you have it written down. If I did, I can't find where I wrote it. So just that AB has to be equal to BA and has to be equal to the identity matrix. Okay, so you're looking for the matrix that's got the ones on the diagonal, so something like this. Okay, and so on. That's what your answer should come out to if it is an inverse. Alright, so let's look at 34 then. So 34, we have matrix A is -2, 1, 3, 1, 2, -2, 0, 1, -1. And we have B is 0, 1, -2, 0.25, 0.5, minus 0.25, 0.25, 0.5, minus 1.25. Okay, and you're probably like, why are these all decimals and stuff like that? Well, it's because of what happens when you do the inverse of something. Okay, and this is part of the reason why we're not actually finding the inverse by hand of this. Okay, or why we're not, it's not really a good way to put it, why we aren't just typing this in our calculator here, or sorry, why we are typing this in our calculator to verify it rather than doing it by hand, because of all these decimals and stuff that end up being weird, and why I'm not requiring you to find the inverse of a matrix like this by hand. Okay, the only ones I'll require the inverse of is a 2 by 2, which we'll look at in just a minute. So, grab your calculator, and we're going to type these two matrices in. So remember, second, then this little x to -1 has the matrix above it, and we need to go to edit. I've got 3 by 3 matrices, so I got to change that, and now I can just type everything in. So if I'm going a little bit faster than you're typing in, just pause it for a second to get everything typed in. And then I'm going to go in and do the second one. So this one, make sure you pay attention to your decimal places. Be a little bit more cautious when you're typing these ones in. Okay, so I'm going to go back and check and make sure I typed everything in correctly on this one, because if not, I'm going to end up having a problem. Alright, so then you're going to go second matrix, and we're going to do A times B first. Okay, so all I would want you to show on your paper basically is you need to show me that you are checking it. Okay. This gave you the identity matrix, so you would say that that's equal to I, and then I'd want you to verify it the other way. Second matrix, B, and then A. So then I would want you to just show that you checked it the other way, and then that is equal there. And then just give a little check mark, basically saying that it is true. Okay, so this is what I expect to see on your paper for these problems. Alright, and then the next section here, we will be finding an inverse by hand. So I'm going to put the info back up for that just real quick, which you guys have the ability to print these off, or you could write them down if you wanted to. But finding the inverse of a 2 by 2 matrix, we're doing this by hand, okay? So we have AD minus BC is not equal to 0. So basically the determinant is not equal to 0. So then we take 1 over that value, so whatever this value was. Okay, and then we multiply it by, we flip these D and A, and then we put negative signs, or opposite signs is what I really should say, on B and C. Okay, so we're going to look at one of these, okay, and like I said, the very first step is to check and make sure that AD minus BC is not equal to 0. So, for number 36, find the inverse. Alright, so we have 6, 3, 10, and 5. So the first thing is I'm going to do the AD minus BC. So 6 times 5 minus 3 times 10. 30 minus 30 is 0. Therefore, no inverse for this one. Okay, but if there were, just so I can set this one up so you can see it, if there were, we would have 1 over this value here, okay, so 6 times 5 minus 3 times 10. And then times, we'd flip these, so 5 and 6 flip, and then this would be negative 3 and negative 10. Okay, for this one, this is not true. So this is not true for this problem. I'm just showing you how you would set it up because the one I'm giving you does, in fact, have an inverse. So, just wanted to make sure you could see that set up. All right, so let me show you how to just check in case you think that you did something wrong. I'm going to go type this matrix in. I'm just going to put it in matrix C so I don't have to adjust a whole lot of stuff here. Second matrix. Oops. Let's see. Need to go to the edit option. I need a 2 by 2. So I'm just going to type these in. 6, 3, 10, 5. So if I wanted to check this and make sure I'm correct, okay, I'm going to pick that matrix, and then I'm going to use this inverse button here, which is right below the matrix button. And it's telling me that it is singular, okay? It just told me it's singular, which from our definitions that we wrote down means that it has no inverse. Okay, so your calculator will even verify it for you if you're unsure. Okay, but you do have to show work for the one I'm requiring you to do. This is just a way to go through and check it. If I were to change it, let's say I changed it to, let's change one number of it and it would work. Let's make this a 5. Oops. So matrix C, inverse, and now it has an inverse. Okay, so just by simply changing one number, all of a sudden, I now had an inverse of this matrix. So just to show you that your calculator can do that for you. This is how you would go about doing something like 37 or 38. Okay, you would check it by this method here, just with your calculator. And I'll give you a list of which ones you can do on your calculator in just a minute when I give you your homework problems. But we need to do one more problem. Okay, we are going to, so 41 and 42 are to use the definition to evaluate the determinant. So I'm just going to do an example because the only one I would require you to do the determinant of is a 3 by 3. So I'm going to just do an example of that, and then you can do the one out of the book. So 3, 2, 5, 0, 1, 3, 4, 2, 1. Okay, and you have to show this by hand. Okay, I'll let you verify it on a calculator, but you have to do it by hand. So, remember when we set up the determinant of a 3 by 3, okay, we have A times the determinant of the 2 by 2 that's left over. Okay, and then we have B times the determinant of this 2 by 2 that's left over. Okay, and so it follows this pattern here. Okay, so that's all you need to do because this is open book, open notes, whatever. This is all you have to do is follow this simple little pattern here. So, the first thing I have is going to be 3 times, so 1 times 1 is just 1 minus 3 times 2 is 6. Now outside it's minus 2 times 0 times 1 is 0 minus 3 times 4 is 12. Okay, and this is simply coming out of, I'm just not writing all the little numbers in here, okay, because it follows the pattern. plus 5 times 0 times 2 is 0, minus 1 times 4 is 4. Okay, so everything here lines up with the pattern that I had. So if you were confused on where these numbers came from, just match it up here, just like this. Okay, just replace the letters with the numbers. And then this over here is going to be 3 times negative 5 minus 2 times negative 12 plus 5 times negative 4. And that comes out to be, let's see, negative 15 plus 24 minus 20. And so that gives me, let's see, 4 minus 15 is negative 11. So the determinant of that would be negative 11. Okay, and you would use this then ultimately to be able to find your inverse, but it's just a lot if you were going to do an inverse by hand for that type, so that's why we don't do that. But just to verify the determinant, let's do this one on your calculator to ensure, since I didn't make that up, that I did it correctly. Trying to get it without the glare on it. There we go. All right, so second matrix, I'm going to edit matrix A. 3, 2, 5, 0, 1, 3, 4, 2, 1. Second quit. So now this is something I haven't shown you yet, so I'm going to take it a little slower. So second matrix. Now you're going to go over to math. Okay. Now you have the option for determinant. Okay, DET is for determinant, so you're going to click that one. And then you're going to go back, second matrix, select the matrix that you used, hit enter, and the determinant is negative 11. So what I would want you to just show me if I were to ask you to do it on a calculator or to verify with your calculator would just be to say the DET of matrix A is equal to negative 11. Okay, so that'd be how you would show that you checked it on your calculator. Okay, but otherwise I need to see work if I require it by hand. So let's just, a 4x4 follows the same pattern, but it gets a lot crazier. I had to do one of those in college on a test in my calculus class where we had to do a 4x4 matrix taking the determinant of it, and no joke, I think it took me like 25 minutes and I still didn't finish it, but we ran out of time. And that was just one of the questions on my 50-minute test. So this is why, that experience is why I only require you to do 3x3s by hand, and then from there I'll let you use a calculator. So just to show you 42, you don't actually have one that's this hard, but 42, okay, the matrix is 1, 0, 2, 0, 0, 1, 2, 3, 1, negative 1, 0, 2, and then 1, 0, 0, 3. Okay, so I'm going to go type this in, and I'll show you what the determinant of that is, just so you can do another one on your calculator. So second matrix, I'm going to put it in B. If I remember to edit it first. So this is now a 4x4. 1, 0, 2, 0, 0, 1, 2, 3, 1, negative 1, 0, 2, 1, oops. See, I already messed up. 1, 0, 0, apparently it didn't click, and then 3. Alright, so with a matrix this big, probably a good idea to check it, but I'm pretty sure I've got everything typed in. If not, oh well at this point. So second matrix, math, determinants number 1, and then second matrix, I need matrix B, because that's what I put it in. And so that comes out to be 10, so the determinant of this is 10, courtesy of my calculator. Alright, so that's the last of this section. We'll be doing one more section dealing with matrices, okay, but pretty much, because I don't think any of you are probably going on to actually major in math, so I don't really need to spend a ton of time on the next section in terms of doing it by hand. We're pretty much going to do it on the calculator, so Make sure that you use this section to get comfortable with doing matrices on your calculator, because that will help greatly in the next section. But your homework for this section is, let's see, I'm going to list out the problems individually, and if I circle them, they can be done on a calculator. So, let's see, circle problems, calculator. All right, so let's see, we need to do 29, 31, 33, 35, 37, 41. That looks good. All right, so let's see. 33 can be done on a calculator. 37 can be done on a calculator. 41, I want you to do it by hand, then calculator. Okay, so you can do it by hand, but then you can show it on the or you have to do it by hand, then you can show it on the calculator, just so that I can see that you understand that going forward and everything. So, not too many problems for this section. We'll have one more section for this week in particular. Hopefully I'll get that out sometime tomorrow. And then I'll give you some review problems that will be due on Monday, a quiz on either Tuesday or Wednesday. I can't remember what I said yet. And then probably one more like small section that'll just have some homework on it. So have a great day, and I'll get the next video out to you as soon as possible.